All right, I'd like to say what's up to all my subscribers, all 36 of you. So if you dig my videos, please hit like, hit the subscribe button. Tell all your friends to watch my videos. And I become big. So I told you guys, if I become big, if I ever get any like a royalty check, or I'm just gonna put all that money into my classroom. Then I'm gonna donate a lot of money to the school. Because this is my job. Like it wouldn't be fair. It wouldn't be fair. Well, who's gonna watch my videos if I ain't making videos? I make videos for you guys. Oh, you're saying if other people? Like I could.
You could still go over it at home.
You're right. You're right.
Like, you know how a lot of people.
Yeah. Yeah. I could, man. I could be like super famous. I don't know, man. If that happens, you know, I got to remember the small people. I got to remember the little people. So, Picardo's Polynomials. All right, I dig it. We could change my channel and call it Picardo's Polynomials. I would be all for that. I don't know. Right now, I'm just really happy that I have any subscribers. People are watching my videos. Awesome. Makes me feel good. All right. Guys, all we did yesterday, the major focus of yesterday was for all of us to come with an agreement that when I have a square root, all right, so just a quick review. Anytime I have a square root, what do I know about the thing that has to be underneath it? Is it allowed to be positive? Yes. Is it allowed to be negative? No. Is it allowed to be 0? Yes. And that was the big conversation from yesterday, right? And we looked at what one of those looks like graphically, yes, right? But the big takeaway, guys, was what things am I allowed to put into a radical, okay? So what we're going to do today is we're going to figure out how to solve a radical equation, okay? And it's actually very easy to do if you pay attention to this very, very first statement. To solve anything that has a square root, you need to isolate the square root expression. What does the word isolate mean? Get it by itself, right? You want to get the radical alone by itself. Huge. So I don't even want to think about steps 2, 3, and 4 right now. I just want to know if that first step is done. So in example A, is the radical by itself? Everybody, yes or no? Yes. In example B, is the radical by itself? Okay, so I hear some no's. Does anybody want to argue that it is by itself? Jaden wants to argue that it is. Well, argue. So you're saying because there are things underneath it doesn't matter as long as the radical is the only thing on that side? What do you guys think? You want to adopt that? All right. If I read the left side of this, what would I say? The square root of x minus 3. Would I add anything to it? No. Is it being multiplied by anything? Divided? So the only thing on the left is a what? Radical. In example C, is the radical by itself? Yeah, it is. Now there are things under it, but the radical's alone. So with these first 3 examples, guys, there is nothing to do. Is the radical by itself? No. So this is what I want to do, guys. I want to get this whole thing alone. So what do I need to do to get that alone? Give me something that I can do. Simple step. Add 4. Now, somebody read that left side. It says 3 times radical x. So is the radical by itself? No, because there's what with it? The 3. And what's the 3 doing to it? Multiplying. So to get rid of it, now the radical's by itself, right? All right. Guys, this is the key. If you can get to this point right here, you should be in good shape. All right, we'll talk about the next steps, but that's the key. What do I want to do here? I want to get this whole thing by itself. So what am I going to do first? Subtract 7. And then divide by 2. And now is the radical by itself? Yes. Well, here in F, I want to get this whole thing by itself, right? So what am I going to do? Add the 4. Yep. And now is the thing that I highlighted by itself? It is, right? Okay. So Hezzy, that's the key, right? I got to get it to look like this. I got to get the radical by itself. Everybody good with that? Okay. What's our second step say to do? Square both sides of the equation. Remember that squaring cancels a square root. Because what's the opposite of squaring something? Square rooting something. So if I have something that is square rooted and squared, what happens? They cancel out. Absolutely, right? So in this first example, I have it in the isolated form that I want, yes? So that means that I square both sides. Now by squaring both sides, what happens? It cancels out the square root. And I'm left with x equals 49. Square both sides. And what happens? It cancels out the square root. Good. Square both sides. Mm. 8.5. So fractions can happen, right? That's not crazy. We okay with that? First 3? All right, how about over here? Square both sides. That was an easy one. Square both sides. Square both sides. Feel okay about that? All right. Guys, go back to those directions for a minute after you finish writing those down and read through that last step. Because what did I not do? I didn't check any of these, did I? Right? Now your first question is, whoa, Picardo, now I gotta check. Why you gotta add steps? Why you gotta make this hard? Right? But guys, I want you to think about yesterday's lesson. What was yesterday's lesson? Yesterday's lesson referred to the fact that what? Radicals have limited domain, don't they? They have certain things that we're not allowed to plug in, don't they? They have certain things which creates problems when I plug it in, don't they? Yes? Yes. So, what I want to do is I want to really quickly talk about how we check in this class. Guess what, Blake? We never, ever plug things in by ourselves. We always let the calculator do it for us. So if I wanted to check this last one, right? Kind of complex, correct? Plugging in 22, pretty easy to make a mistake, yes? So all I'm going to do to check 22 is do one of these, right? I'm going to say, okay, let's take 22 and let's store it in for x. Yes, you could. And we're going to talk about that in a minute, actually, on the next example. So, want to check the 22, right? So what I do, stored it in for x. Now, all I'm going to simply do is what? I'm going to type in my original problem here, and it's going to give me a true, false answer, isn't it? So is 5 times radical 3x minus 2 is 5 times radical 3x minus 2 minus 4 equal to 36. Would it be one of, I can see it. No, that's 5 times. It's not a fifth root. That if it's a fifth root, it's gonna be subscripted, smaller, and inside the radical. And what did it give me? Give me true, right? Okay. So for all 6 of these guys, right? I'm not going to do this, Blake. I'm not going to go through and type these all in, but you could easily check these, and in fact, you must. Okay? You have to check them. Not optional. Have to do it. You're going to see why in a minute. Okay? But for right now, let's just pretend check, and we checked, and we checked, and we checked, and we checked, and we checked. Now, Jaylani makes a very good point. She says, why can't I simply end solve these? And the truth of the matter is that would be an extraordinarily smart idea. Why wouldn't I? Right? Why wouldn't I? So I want to end solve this. And again, guys, Jaden, end solve is not one of those optional things that it would just kind of be nice to know. You got to be able to do it, right? And on a problem like this, if you're solving it by hand, you're silly, aren't you? Right? So I go to end solve, and is 3 times the radical x over 2 equal to 15. Equal to 15. Now, guys, when I end solve it, if I ever hit enter and I get this, what did I not do that I needed to? Comma x, right? If you ever don't do the comma x at the end, it'll say too few arguments. The function or command is missing one or more, and that just means that at the end of this you had to do your comma x. And there's your solution of 50, right? So this would be a perfect way to answer that question. And in fact, that's how you probably should do it, right? Awesome. All right, let's see how last unit plays into this unit again, okay? Guys, look at this first equation here that I give you. I give you y equals radical x plus 3. Talk to me, since you were so good last unit, about what that does to our graph. It shifts it to the left 3 units, right? So yesterday we said that a regular graph for radical x looks like that. That's just your radical x graph, right? And remember that there were some key points on it. There was 0, 0, there was 1, 1, there was 4, 2, there was 9, 3. So that's just radical x, right? So you guys said that when I do radical x plus 3, that just takes this graph and shifts it to the left 3 units, right? So all I'm going to do is take my points and move them to the left 3. And that creates this. I'm going to get rid of this blue one. We don't need this blue one anymore. So that's y equals radical x plus 3. Of course, you could do what? You could plug it into the calculator, right? And you could see it that way. Agreed? That's what he's doing. Smart. What's this other one going to be a graph of? Y equals x plus 1. What's that going to be a graph of? Straight line. With a y-intercept of and a slope of 1. All right, let's graph that. Y-intercept of 1, slope of 1. And Caesar, of course, could do what? Graph it on the calculator. I tell you, when I have a system of equations, the solution is always what? So what's the answer to this problem? If I said, what's the solution to this? It's the answer, but what am I looking at, or what am I looking for when I want the solution to this? The point where they intersect, I tell you, right? And so the solution for this would be this point right here at 1, 2, right? So the solution to a system is always where they what? Where they intersect, right? So you should be thinking to yourself right now, and if you are, I would expect that that would be normal. Why am I doing a system of equations? What does this have to do with radicals, right? What does this have to do with radicals? Well, let me show you. How many places did this intersect? How many solutions exist? 1. One answer, right? There's only one solution. Now, watch what happens down here. It says, now I need to solve this algebraically, right? I want to solve this algebraically. What do you guys notice? These are both equal to what variable? If they're both equal to y, then can I set this equal to this? So can I set this equal to this? Because it's a system and they're both equal to y, and substitution allows me to do that, doesn't it? Go back to last page now. It's a equation involving a radical, yes? The first step to solving one of these is to get the radical by itself. Is it? Yes. Okay. The second step to solving this is to what? Square both sides. Now, that statement right there is huge. What's on the right side of this? X plus 1. So what do I need to do? I need to square both sides. So what did I do? I put the x plus 1 in parentheses. That's your key step to this, guys. That's what's going to make this a little bit more challenging now. So what happens to the radical when I square it? Makes it go away. And so I have x plus 3 equals x plus 1 squared. Now remember, guys, that x plus 1 squared is x plus 1 times x plus 1. So what is that going to require me to do? Distribute, double distribute, FOIL, tic-tac-toe, however it is that you multiply two things times two things, right? If you like to FOIL it, FOIL it. If you like to tic-tac-toe it, tic-tac-toe it. I'll FOIL it. Right? Had to FOIL it. Okay. Guys, you're seeing how like the last couple of units are starting to play in this one a little bit. Okay. Now, are there any more radicals in my equation? No. So I've done everything I need to do for this unit in terms of how to solve this. So now I got to go back to a previous unit, don't I? And what do you notice is in this equation? An x squared. When there's an x squared in it, how do we solve equations with x squareds? We move everything to one side to create a quadratic. So now I need to move everything to one side. So Trinity's doing some analysis right now. I like the fact that when Trinity takes her notes, see, here's the thing. Like when I have students that sit next to me or near me, I get a real good sense of what they do. So Trinity's not just one of those scribers, right? She doesn't just write it down. She actually looks at it and thinks about it first. Don't you? She does. And I watch it. Like she'll look up there and she'll see if she understands what's going on, and then she'll write it down. So don't just be a scriber, be an understander, right? I moved everything to this side, and then what I do? I combine my like terms, right? So 1x and 1x is 2x minus x is 1x, and then the 1 minus the 3 is the negative 2, right? Yeah. So I get it in this form, and now we go back to our quadratic unit. How do I solve a quadratic? I factor it. So I got to factor this guy. And I need two numbers. All right, Jelani says x plus 2 and x minus 1, and I would agree. Those are two numbers that multiply to be negative 2 and add to be positive 1. And once we get to that point, we take these factors and we set them equal to 0. So we get x equals negative 2. And we get x equals positive 1. I got a really important question. How do I know something's wrong? Because how many solutions did I just come up with? 2. But how many solutions really existed? Only 1. So that's why we have that last step that says that we're supposed to do what? Check. So what I'm going to do is I'm going to go all the way back to my original, which was this. Now again, what can I do? I'm going to use my calculator to check, right? So I want to know, does negative 2 work? Well, let's do it verbally first. What's negative 2 plus 3? Positive 1. Negative 2 plus 3, right? What's the square root of 1? 1. What's negative 2 plus 1? Negative 1. Is 1 equal to negative 1? No good. So this we're going to reject. All right, we're going to check 1. Now we already know 1 works because we did it up here graphically, but what's 1 plus 3? Square root of 4? and 1 plus 1. So there it is, right? So we see that it checks. And we could do that obviously with our calculator. So this right here, guys, gives me what? Gives me some opportunity to have answers that don't work, okay? And there we see it. We saw it graphically too, didn't we? Okay. All right, I'm gonna do one of these, then you're gonna do one of these, and then we're gonna do the last one together. Algebraically, find the solution. Guys, this is essentially the exact same thing that we just did in the previous page, right? The problem even looks the same. Is the radical by itself? So I'm supposed to just square both sides. Now, when I square both sides, because there's more than one thing on the right, I need to put it in parentheses. That requires me to FOIL it or tic-tac-toe it. Gives me that. And again, you should have some thoughts in your mind, guys. One of those thoughts should be, okay, Picardo said when there's a square in a problem, that means it's quadratic. So I got to move everything to one side, right? Yeah, so I'm going to wind up moving this and this over, right? Combine my like terms. That's negative 8x plus 12. Factor it. Got them? What are they? Negative 6 and negative 2. Because those multiply to be 12 and add to be negative 8. Which gives me some answers of 6 and what? And 2. Go ahead and check it. I'm not going to tell you which one works. I want you to figure it out on your own. One of them will work, one of them will not. Take a minute. Use whatever method you want and figure out which one works. Again, do it the way that you know will work. Do it the way that you know you're going to get the right answer. Don't plug it in by hand. You guys think you got one? Which one does not work? 6 or 2? 2's no good. Good job, right? And again, If anybody's going to ask me, Mr. Ricardo, how do you know 2 doesn't work? What am I going to say? I stored 2 into the calculator. I typed the equation in, and it said false. Yeah, it said false, right? I mean, literally, that's what we do, okay? All right, so I already see some people that are starting this problem. What do you guys think we need to do first? You got to move the 2 over because you can't do anything unless the radical's by itself. Now, I'm going to tell you right now, the algebra on this one's going to be a little more challenging. Yeah, go ahead. If it's not, then what's going to happen? Hang on, I'll show you. All right, so that's where we get when we square both sides, right? If you didn't, what you would have is this. You would have 2x squared equals this squared. Now, what the problem with this, and Jane, what's going to wind up happening when you do this is you're going to wind up with a really ugly tic-tac-toe problem because you're going to have 2 things times 2 things, right? This radical would wind up canceling, but you would still wind up having radicals in the problem. So the radicals wouldn't go away by doing this. By just keeping the radical here and only the radical, it will eliminate it. Okay. There are ways to do it that sort of surround what I just showed you there, but it just becomes way too complex. So this is 2x plus 2. So the foiling's a little more challenging here, right? What's 2x times 2x? 4x squared. The outers is 4x, and the inners is 4x, and the 2 and the 2 is 4. All right, and so we see a square in the problem, which indicates to us that's our trigger to move everything to one side, right? Okay, so again, we're looking for triggers, hints, right? Things that lead us to our solution. And we get here if we've done this right. And we know that our next step is to what? Okay, good. So we got to factor it, right? And so that brings us into our bag of tricks. And one of our bag of tricks of factoring is, when this isn't a 1x squared, when it's a 4, I got to do one of these. So I need to find factors. I need factors of -8. I need factors of -8. I need 2 numbers that multiply to be -8 and add to be what? 7. Azim, my man. 2 numbers that multiply to be -8 and add to be 7. Close. +8 and -1. +8 and -1. Those multiply to be -8. Those add to be +7. Now, when I write out my factors, what goes in front? The 4x plus 8 minus 1. How do I finish that technique? Because there's one more step I got to do. Factor a 4 out of 4x plus 8. Very good. Yeah, so factor that out, and that gives me an x plus 2. The 4x minus 1, there's nothing I can do with that, is there? So I have 2 factors. I set them both equal to 0. So I get a solution of -2. And I get a solution of 1/4. Now again, do you really want to plug in 1/4 by hand? Oh, right, that would be a total pain, okay? The one that works here, guys, is going to be the 1/4. So again, you can check this on your own. the negative 2 would be rejected. The negative 2 would be rejected. No, do not assume that. It all depends on what's under the radical. Now you're probably thinking to yourself, oh boy, we got another example to go. Think I got this. We'll do one more example. Okay. Well, watch how quick this one actually goes. Ready? If I asked you to graph this, forget about the 3. If I asked you guys to graph that, what would it be? It'd be a radical that's been shifted to the left 2, up 4. So would it be fair to say that it would look something like that? Can we all get on board with that? Yeah. Now, what if I asked you guys to graph 3? What would you graph? A straight line. Where? Starting at 3. So it would look like that, right? Do those things ever meet? Never, right? So how many solutions do we think there's going to be to this equation? No solutions. They don't ever meet, so there shouldn't be any solutions. You want to know why? Here's why. Guys, to solve this algebraically, what do I need to do? Get the radical by itself, which means subtracting 4. So doesn't that bring me to this? What's the problem with that? There's no way that my radical can ever equal a negative 1. Can't happen, can it? And so that's why this has no solution. Can't do it, right? Can't do it. And we see a good graphical reason why, don't we? Okay? Now, if you tried to solve that by hand, guess what's going to happen? You're going to get answers. But guess what's happening when you're plugging them in? They're coming out false. They're coming out false, right? But to save time, we don't need to, right? We see graphically and we see algebraically why it doesn't work. All right, guys, you have 2 things that you can be working on in the next 13 minutes. You have homework 1, homework 2. That's pretty much it. Sound good? Awesome.